Hello and welcome everyone from around the world to Elektor Lab Talk number 18. We've got people from Belgium, North Carolina, and we're of course from all around the world ourselves. I'm Brian Tristam Willams, and today we're diving into test, measurement, and repair. Joining me now is Jens Nickel, our editor-in-chief. Jens has a lot of knowledge and experience in electronics and will share his insights on the latest in test and measurement. And he's joining us from Aachen in Germany at Elektor Labs. Next, we have Saad Imtiaz coming to you from Islamabad, Pakistan. He's a talented engineer known for his innovative projects, and Saad will talk to us about practical tips and tricks for repairing electronics. And finally, of course, Jean-François Simon, who comes to us from the west of France, and he has extensive experience in electronics repair and testing. He'll be discussing some case studies from his experiments, and we'll chat about our summer circuit, special circuits packed with exciting new projects and ideas. So, how are you guys today?
Hello,
I'm fine, Brian.
That's great. Jens, you're looking good. I think you have a new camera there.
It's actually the same camera as last time, but okay, maybe it's a different angle and we have very sunny weather here in Aachen. So, yeah.
Okay, well, we'll see in 1 hour how the light changes because it's winter there. Well, it's almost winter. Summer down south here. Anyway, for our audience, thanks again for joining us. We have a great giveaway. If we can put that up on the screen, it's our Lab Talk giveaway as always, and it's a brand new product. It's the Arduino-based Elektor MultiCalculator kit. It just landed in our store, and it's Arduino-based, and you can build it yourself, and which means that obviously it's completely programmable. It's built around a Pro Mini and powered by USB-C. So you can assemble it yourself and you can make it do whatever you want, I'm sure, if you're as enthusiastic as we all are. But we'll tell you details on how to enter that later. For now, though, let's dive into the latest issue of Elektor Mag. There's the cover and some highlights from it. The focus is on test and measurement this time around. And naturally, if you're testing, you're also repairing. And that's where Jean-François will help us out today. A sample of some of the projects, digital bubble level, in-circuit LC meter. And let's take a look at the table of contents. Jens, we all worked hard on this one. And we're clicking at the same time. Let's take a look at what's inside. Jens, how was this putting this together for you?
Yeah, of course, I'm not working alone on this edition. You are the editor's team and our engineers in the lab. They also contribute, and of course we have a lot of external authors contributing to that edition. And yeah, I think together we made a really great edition full of interesting projects. And yeah, that is maybe a little bit a specialty of the test and measurement edition. There we really have the option to bring the really big analog projects again in the edition because, yeah, test and measurement, that is not always, but in some cases or in most cases, it's analog measuring. And yeah, we have really great and big projects. You have to be precise. You have to have clever circuit tricks in it. So yeah, that is again the time of the year where we can present these 1-page or even 2-page circuit diagrams. And I know it's popular amongst our readers. For example, for our 10 megahertz generator, we get nice feedback from readers. That's exactly what they looked for. And yeah, maybe we can dive into some of the projects now. Yeah, for example, the 10 megahertz reference generator, that's only one example that's coming from our regular author, Alfred Rosengrenzer, who is really an expert in test and measurement. He was a professional engineer for decades, for example, in the telecommunications industry. And yeah, also in his spare time, he's working on test and measurement project. And that is just one example in a long row of analog and audio devices he's working on. And yeah, what is a reference generator? Yeah, if you test and measure something, you need a kind of synchronous generated signal. So all the devices or the modular devices, they know exactly what their time is, so to say. You have 10 megahertz, which is quite common. That you use 10 megahertz signal, which is distributed to the different modules. And yeah, you can see in that block diagram, you have, I think there are 6 outputs where this clock is distributed to. And yeah, you can read in the article that you also need some galvanical isolation to prevent ground loops, and that is done quite properly. And you can see on the left, as the source of this signal, you have more than one option. For example, you can take, if you have already an external reference generator, you can take that signal, or you can take a simple quartz, depends on the precision you need, or you can take an open control quartz crystal. And yeah, Alfred is describing that very well. He's also offering PCBs. And yeah, you can read anything about it and the different options, because it's a very modular project, and you can adapt it to your own needs. It's very versatile.
That's great. Alfred Rosenkrantz as well has a great wealth of experience on that. So
yes,
this article you can find in our latest edition. And 10 megahertz, what would you typically use that for as a reference?
Yeah, as said, when you have measurements, for example, for audio equipment, then you can use this reference signal, but yeah, also for RF measurements and all kinds of measurements, because normally you don't have only one, let's say, test point or point where you measure something. You have more, and sometimes you have different channels you want to know, you want to measure, and there you need a clock, a common clock signal.
Yeah, from my analog video days, I had reference signals, but they were 3.58 megahertz or 4.43. Never had to go quite as high as 10 megahertz. Anyway, let's talk to Jean-Francois now. He's going to tell us about repairing electronic equipment. That's his latest article in the latest edition, which many of you have obviously read already because you have the magazine. But Jean-Francois, can you give us an overview of what you did here?
Yeah, thank you, Brian. Before joining Elektor, I used to be a repair technician in an industrial repair company. So it was a very interesting experience and a hands-on experience. So that gave me the idea of making a little article about repair. So as it is a bit of a tradition, the article begins with tools that you can see on the next picture. So very basic tools such as power supplies, multimeters, oscilloscopes, soldering equipment, etc. And also less common tools such as tools to limit the current when you're testing a power supply, for example, or component testers or ESR meters, etc. And then the article continues with tips and methods that you can use for testing. One of which is open your eyes, because sometimes there is visible damage, such as here, a cracked diode on the left and burnt resistors on the right. And very often it's very interesting to look at the visible damage, because it can pinpoint on the board the area where the problem is. Of course, sometimes there is more damage than that, but still that's a good start. And there can also be missing components or burn marks or liquid damage, or all of which can be seen with naked eye or with a good magnifying glass. So this is the first step, and of course the article goes on with other methods that you can use and to test functional blocks, etc. And another tip that I can give you right now is the importance of cleaning. very often the problem is a problem of dirt or residue between tracks, making short circuits, or dirty switches or contacts. So make sure you have a good assortment of cleaning tools, such as brushes and solvents and contact cleaners and all that. And next, this is not in the article, by the way. This is a mains socket with the switch, and I find it really important to know whether or not your circuit is live or not, because you really want to avoid soldering on live equipment. It's very dangerous. It can be dangerous for you and for the equipment, because you can make a short circuit between tracks and pins with your soldering iron. So you will create more damage than you will fix. So I highly recommend a mains plug like this one with a switch and a little neon bulb that indicates if you're on or off. That's great. And still on the topic of safety, this is a few tips and tricks to probe on live circuits for testing after you, when you're in the process of making your diagnostic, or after you replace a component, you will have to test by plugging in the power. And I recommend not to touch the circuit with your hands and risk slipping with the probe. Again, you will cause short circuits and frustration because you will destroy components. So what I recommend is to solder a little piece of wire to the node of interest, like on the right, the orange wire. And then you can clip it with the multimeter probe or oscilloscope probe. Or the other option is to use some good quality, very thin wire grabbers, like the ones from Easy Hook that you can see on the left. And to conclude on the topic of safety, this is an isolation transformer. And I didn't mention this in the article because it would deserve a whole article in its own. So some people swear by it, some other guys swear by isolated differential probes for oscilloscopes. It's a bit tricky because these kind of transformers can give you a false sense of safety. You can think you're safe, and in fact you're not, because it can defeat the purpose of some safety devices such as RCDs or GFCIs, which are the devices that you have in your mains panel that will interrupt the current if you touch the live wire. And if you're after a transformer, then this won't work and you can burn to death. So yeah, I recommend being very careful and read lots of documentation before attempting repairs on live, before attempting testing with oscilloscope on mains power supplies. And you better use isolated equipment such as the portable multimeters or isolated differential probe for your oscilloscope. And with that being said about safety, I think I will hand over to my colleagues for the next topic.
Okay, before you hand over, I just want to...
Jean-François, I have a question. And yeah, you describe in that article quite nice method to limit currents. You use in candescent bulbs, classical light bulbs. Where can you get these light bulbs these days? Because they are no longer sold in the shops.
Yeah, it's a good question. I don't know for Germany, but at least in France, they are banned too. But some of them are still available where they can't be replaced with modern versions, such as for example, in your kitchen oven. It's not practical to have a LED bulb that can withstand 400 degrees. So these can still be found. And also the one I used were really small ones, G9 halogen bulbs. And last year or the year before, they were still for sale. But in any case, I think you can easily find them in the classified ads in wherever you are.
Yep.
You know, I thought you were joking when I saw... Continue, Ian, sorry.
I wanted to ask a second question.
Yeah, sure.
Go ahead.
Of course, it's very helpful to have the circuit diagram of this device you want to repair. Is there a common source in France where you can get circuit diagrams. I know in Germany there was this Schaltungsdienst-Lange, I think, if I remember it correctly. Is there in France and in other countries also a common source where you can get circuit diagrams, or what is the right procedure?
No, I don't think so. I've never heard of something like that. And when I was doing repairs professionally, we almost always never had the schematic. So you have to interpret the board that you have in front of your eyes and look in Google, of course. Sometimes you can be lucky and find the schematic, but it's very rare. And we don't have an official system in France to keep a database of schematics.
Okay, we have a slight satellite delay. Maybe we should say over after every sentence, but I wanted to mention that back when I was about 18, you mentioned having a power switch and seeing that it's on. I thought you were kidding, like check if it's plugged in, but you've got an actual indicator there to show you that it's on. What happened to me is I was snooping around inside of a cable TV decoder, and these days, when you work on a low voltage circuit like your computer, sometimes it has to be on so you can probe it and check with your oscilloscope. But the power supply, the mains power, is normally separate. It's a whole separate thing. But back in those days, the actual 220 volt transformer was soldered onto the main board. There was only one board. And I was busy looking at the low voltage section. I accidentally touched the bottom of the board where the transformer was. And I got such a shock and my tongue was hurting. And I thought, I shot my hand. Why is my tongue hurting? I had bitten through my tongue from the shock. So yes, safety is very important. And those were useful tips there with the isolation transformer and the glowing lamp to tell you you are actually online.
Yeah, of course. In the past, before buying this gadget with the neon indicator, I used to just unplug the time, physically unplug the plug. But once in a while, you are tired and you forget to do so. And if you have multiple cables on your desk, it can get a little bit messy. So a light is great to have a reminder.
Absolutely. Well, we're all still alive for our sins. Let's have a look at, speaking of energy, Saad Imtiaz, our chief engineer, joins us with his ESP32-based energy meter. That's his latest article.
Thank you, Brian. Yes, so in this test and measurement edition, we mentioned another update on the energy meter. Basically, we changed the schematic. We introduced a galvanic isolation with these transformers. Before, we were using resistors, resistive, to step down the voltage to 0.5 volts. But now we're doing with transformers, which make it easier to implement and makes it safer for the further PCB design to be implemented. And also we further breaking down, as we're using the galvanic isolation, we're also excluded the I2C and the SPI line isolator chip. So it further reduced the cost of the energy meter. So now it's really cost effective and also easy to solder and make. We slimmed down the PCB quite a bit. So it's about, I would say, 30% smaller than last time. And also in the last version, we only had three single phase, but now one has the, I would say, option to make it three phase and also single phase. If you short the backside of the PCB jumper, then you can make it single phase. Otherwise, you can make it double phase, single phase or triple phase. What we're about to share now is on the future edition of Elektor magazine, where everything is all done. It's in an enclosure right now with a display with two buttons. Right now it's being powered by the step-down transformer on the left side. I'm using it on a single phase mode because it's easier, and I didn't have a DIN rail transformers, 3 of them, in order to get the sampling voltage from all 3 phases. But for a test setup, it is nice to have just a step-down transformer. Before you use a step-down transformer, it's better that you check the output on oscilloscope, because sometimes the output is clipped of some cheap transformers, and then the all sample rate is not correct. So definitely check your transformers before plugging into this system. Moving on, this is the new PCB design. As you can see on the top side, now we have introduced the screw terminals. On the right screw terminal side, we are able to attach CTs, current transformers, and on the left side, you can easily add all 3 phases, single phase, and also a DC input in order for testing. And the main thing that we wanted to do is that making it modular. So if you don't want to use the ESP32 on board, you can use the IOs on the right side to get the data out of the energy meter IC. And also to program the ESP32, there are 2 options. So you can use the USB Type-C and also the RxTX connections on the left side. Here, yeah, you can see that 2 of the transformers I attached to check, let's say, use it in 2-phase mode. But one of my transformers was clipping the voltage, so it was not accurate as it should have been. So I just gone with the single phase mode with all 3 current transformers trying to sample the voltage. And speaking of testing, then I made a test setup in order to calibrate the my current transformers and also the CT gain inside the chip. So basically what I did is that I made a extension cord, rip it in half in the middle so that I can attach my current sensors and also my clamp meter. And with a hair dryer is actually a good load as it can it's varying load. You can start with 1 amp up to the maximum with heat and full fan speed. It goes till 9 amps. And with the extension cord I made, you can plug in 2 hair dryers and go up till 20 amps. So it was a good overall setup to calibrate it. So alongside, when I was checking, I calibrated according to various loads. So starting from the small values, 1.6 amps, and then going till 20 amps, and then taking an average of how it works alongside. Sometimes with these current transformers, there's non-linearity. So it's not linear in terms of current measurements. So at a voltage gain, or let's say a CT gain at 1.6 amp is lower than the CT gain required to get the correct value at 20 amps. So it's better to take your measurements on a wide spectrum and then averaging out in order to get the correct value for the CT gain. And here you can see this is the early picture before it was going into my circuit breaker box. I placed the current transformer into a small plastic enclosure box with the mains wiring on the top with the connector and the bottom into the energy meter. As you can see on the screen, I think it's a little bit blurred out, but actually what it tells is the load on all 3 current transformers and also the sample voltage along with the time. And here, so we integrated this energy meter with Home Assistant as it was easy, and also I am working on the software for this. So I'm gonna share my screen now to get a live preview. Okay, so this is the integration with the Home Assistant with the energy meter, and as you can see, I can see my frequency, my kilovoltage, the entire kilowatt hour I used the entire day, the total amps, the entire per phase current, and also voltage. As you might see that some of the voltages are not 100% the same is that it's really accurate. So even I would say capacitors needs to be really it tuned per phase. It needs to be tuned even if they're getting the same voltage. And what the cool thing about the Home Assistant is that every value, every sensor reading I get is totally saved, and I can even go 5 days back to see what was the voltage, how much of the voltage drop, how much load was on the grid, um, and even my system doesn't crash. Even the amps, the total amps I was using. So it's overall really good integration to integrate with the Home Assistant. And with the Home Assistant, as you might know, there's a big emphasis on energy. So if I have a solar energy setup, which I'm trying to link it with my Home Assistant, but right now I'm trying to figure out with the APIs. But anyways, with this, you can actually monitor how much energy you consumed over the day. You can go back and even you can select, how much time you want to see. As I think on Sunday, I used the most electricity was as I was on home.
Well, thanks, Saad. That's a great presentation of what you did there. The Home Assistant, there's a screenshot, but it was so great to see it running live. And I love your hair dryer. Is that why your hair is always so perfect? It's a great source of load. What else could be a load? What about like an electric heater? Would that work?
Yeah, but it's summer here, so you don't want heater warming up your room. Hair dryer is fine if it's facing the window. Anything can be a load, even I would say an iron, a soldering iron, uh, pretty much anything. But I would say to go with a static load. Don't use motors or anything like that, because when you turn on the motor, there's a current spike, and you don't have an average current to calibrate it to. So mostly a light bulb can be a good load if it's a really big light bulb. A hair dryer, found it convenient, small, and multiple settings. So I don't have to hook up multiple things in order to increase the load, but I can just change the setting, one step heat, two-step heat, in order to vary.
Yeah, and hair dryers are interesting because they are doing a phase control. So you can test your measurement circuit. They are using they're cutting the power sooner or later in the cycle, in the main cycle, to get more or less power. So that way you can see if your measurement circuit is working properly.
Yes, and with this energy meter, I was able to find out that one of my ceiling fan was taking more current than usual. Normally, it should take 500 milliamps, and it was taking 3 amps, and it was quite surprising. So probably I'm gonna get that fixed, and also an air conditioner. So right now, I just have to ask everyone that please don't turn this on in order to save some costs. So it's an overall nice system to have a real-time energy monitoring of the entire system, the entire house.
Saad, this small graphics of the energy distribution, is that prepared in Home Assistant, or did you do the graphics yourself?
No, actually, you just have to set up the parameter. So I just have to select let's say the kilowatt hour where it is getting the reading from. It has a very comprehensive energy section in the Home Assistant, so you can actually select, okay, which unit or which space is using which entity is actually your consumption entity, which is your export entity in terms of solar. Then you can even divide your consumption based on units or areas. And yeah, it's pretty nice. But the coding part is even more easier. Is that with YAML, with ESP Home, you just have to go to their sensor page and then find out what type of values you want to push, and then it just almost figures out by itself what type of values you're getting and the entities, and then you can publish them onto your dashboard and into the energy page.
For the background, maybe we have to say that you showed pictures of the article which will be published in the July-August edition already.
Exactly.
So in May-June edition, you are already presenting the PCB, but all these testing things, they are described in detail in the July-August edition. So we are already giving a kind of sneak preview.
Yeah, exactly. By joining us here on Lab Talk, you get a sneak preview of what's coming up next. And speaking of sneak previews, is Baltic Lab joining us. He's a prominent YouTuber who deals with analog and high frequency, all stuff I'm not very good at. And he'll be joining us next week in a Meet the Maker. So if you visit our Elektor TV YouTube channel, you can get in the queue for that one for next week. Hey, Baltic, how are you doing? Question here from Instagram, which Asma has sent through to us. Greg Mooney has asked, he's new to ESP32 and he's just learning microcontroller design using the 328P Arduino, which I guess means the Uno. Any discussion available about thoughts and concerns about LoRaWAN technology? Must admit, I haven't used LoRaWAN, but I know it's low power and long range.
That could be indeed a very good subject for one of the next lab talks, because Sat is already working on a LoRa project. And yeah, for the September edition. And yeah, we could feature that maybe in August.
Great. I must say, because pretty much everywhere I go, there's high-speed internet available or even low-speed internet. So I haven't had a use case for something that can be long range, low power, and free. But that would be interesting.
Yeah, there are loads of applications. Okay. For example, they use it in parking sensors and all that kind of stuff. And if you have not too many messages to be sent per day, you can have a sensor in a field and transmit data. Some bytes, let's say 50 times a day or something.
So it would be more efficient than having Wi-Fi cover. Parking
much more efficient, yes.
Okay, well, that makes sense. That's it for the questions for now. Let's move on to our next thing. We're going to give you the code word now that you've been waiting patiently for the last 33 minutes and 32 seconds. Join our giveaway. As I said, we're giving away the Elektor MultiCalculator kit. It's a brand new product, and you can buy a calculator in the shops, yes, but this you can put together yourself and you can customize and you can program it. It's based around an Arduino. So please join that. Check the link in the chat. That will be the easiest for you. But if you can't see the chat, elektormagazine.com/Elektor-labtalk-giveaway. And of course, you could just point your cell phone at the screen and you'll get to the same place. So good luck to you guys from all over the world. Into that competition. We were talking about our upcoming circuit special, so let's move on to that now. We have a mock-up of our cover available right there. And the guys have been working on stuff for the upcoming circuit special. And I think, Jean-Francois, we could start with you and discuss your DC load hack.
Yeah, sure. Can you move to the next picture? Yes, thank you. So I've been testing lots of power supplies recently, and while repairing them or otherwise. And in the past, I've been using some power resistors to draw current from them to test them. But it can be a little bit inconvenient sometimes. So I got myself a nice benchtop DC load like this. This is an ET5410A plus. It's about, I think, 180 euros or dollars on AliExpress. It goes from it goes up to 150 volts and 40 amps, so that's quite a lot. And overall, it's quite a nice unit. But what I found is that the fan is really noisy. And my lab is quite silent, and it's about 32 dB ambient noise, and even at no load, as you can see here in the picture, the fan is at the fan gives about 50 dB, so that's quite loud and annoying for me. So I thought maybe I can analyze the circuit that's used to drive the fan. I noticed it's regulated in 3 speeds. And so I've been tinkering and looking if I could improve the circuit or reduce the noise, as you can see in the next picture. Next slide, please. Thank you. So here you can see the DC load open with all my multimeters and all going on. In my repair article, I mentioned that I like having several multimeters instead of one. Here you can see why. So I am analyzing the circuit, and it's quite interesting. I will cover this in more detail in the summer circuit edition. They are using an op-amp in a slightly unusual configuration, and they are using there are some quirks in the, so it's an interesting project to improve on. And speaking of DC loads, there are many options to consider. There is this one, which is imperfect, but which is quite good nevertheless. There are other models too. And you can also build your own, as Sad did. So maybe, Sad, you can give us a few hints about your work.
Before Sad goes ahead,
absolutely.
I just want to answer another question here coming in from Frank de Hert. Yes, you're paying attention, Frank. What is the code word? I seem to have missed it. How many of you are at the entry form right now and not actually watching us? The code word is MultiCalc. There you see it scrolling across the bottom of the screen. So thanks for entering, Frank, but please pay attention. We're trying to talk to you here. Let's move on to Saad. He's created for the Circuit Special electronic load. Tell us about that, Saad.
Yeah, it's fairly really simple circuit. Actually, when I was testing the AmpVolt module, which we created for a voltage and current sampling, I didn't have a electronic load in order to test its limits. So I just created one with a MOSFET. It basically uses an NRF3025 with the PWM coming from an ESP32. I just included 2 LEDs in order to let me know that if it's green, to start increasing the PWM voltage from the potentiometer. And then there's just one small, actually 3 resistors, 2 for the LEDs and 1 for actually the stepping, draining the voltage from the gate. So as my testing, I was thinking maybe let's not put resistor between gain and source, but at high voltages the gate saturates by itself due to high voltage, and it just opens up by itself. So it's really good to have a pull down resistor installed between the gate and the source. So in my testing, I was able to achieve almost 8 amps. As you can see here, it's almost 5 amps. But the thing is that you need to really have a good heatsink and a cooling fan. This heatsink was not inadequate for going 8 amps for more than 30 seconds. So I think I just need a bigger heatsink and a nice cooling fan in order to operate in that high amp area. But all in all, I think it served its purpose well. And it's really nice. I would say if you don't have an electronic load, you just use this one for a couple of seconds in order to test if something goes off or not. Yeah.
Oh, that's great. So it's another load. We had our DC load and our electronic load. So we've got loads of loads coming up for you guys out there. What would the different use cases be for this load versus what Jean-Francois showed us?
I think that is more of a professional load, and this is, if you don't have that one, then you can use this one. But I would definitely recommend go for a proper professional load, But if time is short on your hands and you really need to test like I did, then you can just create this one and get on with it.
Yeah, they're the same kind of instruments, but they can be really expensive. So it's nice what you did here, Sad, because it's nice and portable and quite affordable. So it's a good option.
Maybe we should put you guys together, team you up, fight, see whose load is better. Anyway, the next circuit special we'll talk about is from Jens, our editor-in-chief, who also somehow finds time to tinker in his lab, and he's bringing us a motorized volume potentiometer.
Yes, and of course we three are not the only one contributing to that circuit special. In fact, it's mostly made by circuits projects coming from external authors, coming from our readers. But it is a long-term tradition that also the engineers in our lab, they contribute with at least one circuit. And also the editors. Yeah, I also contributed with an article for the last circuit special. I think not all editions, but yeah, for some of them. And yeah, in that circuit special, there will be one of my first PCBs. So yeah, you may know I'm coming to the electronics more from the side. I'm not a born tinkerer, at least not for hardware, but yeah, okay, I now tried my first PCB. And yeah, I actually, if you go to the first slide again, then you can see what's all about. Sad, I have to say, I'm a little bit jealous about your photographs. They look really professional. How you make them. I'm not as good as you, but okay, you can see the things which are essential. So yeah, it's all about a station for a loudspeaker, for a passive loudspeaker, and it integrates a battery, which you can see in pink at the top. It's actually a battery for bicycles. And you can see a small amplifier, and you can see on the right a receiver for wireless audio transmission. That's the same system they use for these silent disco parties, where everybody has just a headphone on and you can do it very silent and all the people do party and you hear nothing. So it's good for the neighborhood. So it's the same system and we are using it for audio transmission. So you have a completely independent station which gets the audio from some source wirelessly. You have an own battery and you have a small amplifier. And yeah, you just have to take one of these boxes for every speaker and just press the switch. You can see it on the right. And then it works. But okay, you have to manually adapt the volume. And then yeah, if you have 4 of these systems in the field, you have to go around and always adapt the volume for each of the speakers. So a buddy of mine and me, we decided we want to do that wirelessly. And of course, we thought on Wi-Fi and then we thought, of course, on ESP32. So we are using small Shio ESP32 boards. You have seen a similar board when Saad presented his load. It was exactly the same board. And we are using that ESP board also in that box. You can see in black at the bottom. And it gets the information how to set the volume from somewhere. But of course, you have to connect it to the amplifier. And yeah, we first thought on a digital potentiometer. But later, yeah, we decided, okay, that is that there you have too much interference and problems. And we came to classical motorized faders. And if you think on motorized faders or motorized potentiometers, I have to say, then you think immediately on Alps. And yeah, in fact, these apps, motorized potentiometer, they are quite old, but they still sell thousands of them, and you can see it on the right, because I did some research in Elektor archive, and I discovered exactly what we need, a PCB for an Alps potentiometer, and it was exactly the same type we were also using. You can see it on the right. It's in fact a stereo potentiometer. And yeah, that guy who made that article, it is from 2008. He used that stereo potentiometer to control left and right channel in a synchronized way. So yeah, that is maybe the common approach you would take. But we are using that a little bit differently, because we have already one electronic box for left channel and one electronic box with another potentiometer on the right for the right channel. Then we don't need a stereo potentiometer. So we just took the second winding of that potentiometer to get a sort of feedback. And here comes again measuring into play. We measure the resistance of the potentiometer in that right channel. And then we put that value into our ESP32, and we send it back to the controller. So we know exactly the volume that potentiometer has. And yeah, here you can see the circuit diagram of that old article. You can see this guy made two boards, and the one on the right, that is the potentiometer board in fade green with fade green background. And you can see the connectors to the amplifier. And yeah, you can see there are 4 of them, not only 3 of them, but you can see here 4. And yeah, that has some implication, that has some reason. And yeah, we took exactly the PCB. I think we can see it on the next slide, the PCB of that guy. You can see it on the left. That is the PCB for the potentiometer, where you can solder it. And to make our own PCB, I used that drawing and put it in KiCad and made my footprint with that PCB image. You can easily import images in that footprint editor, and we can see that on the next slide. So that is the footprint editor in KiCad, and I just made that drawing black and white, and then I had exactly the points where I wanted to place my pads, and that was the footprint for our potentiometer. Yeah, and now to that force connector, you can see it on the bottom left. Yeah, that is a connector where you can get the ground of that amplifier, and you can connect that ground further to the ground of the controller. And there you can prevent interferences. So that was a good trick, so to say, because I have to say my first PCB just had 3 connectors, and later then I just took a wire to ground it. And yeah, my next PCB, my current PCB, also has these 4 connectors. So that was really a good thing, which that also did in 2008. And maybe we can see more on the next slide. Yeah, that is the circuit diagram. Yeah, you can see it's rather simple. You can see a growth connector, and that is connected to an ADC. an external ADC, and you can see a screw terminal where you have exactly these 4 pins. And on the right, I also took that trick from that guy from 2008. There is a dual LED, which gives you a hint in which direction your motor is driving. Yeah, and you can see our PCB on the next slide. That is the PCB, and then we also have a 3D drawing in the next slide. Yeah. So that's a very good feature in KiCad. You can have a 3D drawing. Unfortunately, we don't have a 3D view of the potentiometer, but yeah, you can do our own. You can do your own 3D views of your own components. Yeah, it will take some time, but we could do it. And yeah, on the next photo, you see that potentiometer soldered on the PCB, and yeah, it's built in a housing, in a very cheap housing. And here you can see the whole electronics box in full glory. And yeah, actually, we connected the pins of that potentiometer to a GX16 connector, which is very common in aircrafts. I had to learn this. I searched for connectors which are reliable, and yeah, these are really industrial grade connectors. You can get it, for example, at Reichelt, but also at Alibaba and so on, and Amazon. And yeah, you can get them in angled versions, and you can get them in 3, 4, 5, and other versions. So these are quite good and reliable connectors, and you can screw them together. So you are not at the risk that the connection is breaking in the field. Yeah, that was it actually. And yeah, I will report on that in the Circuit Special. So that will be my contribution. But of course, we will have many, many other circuits and projects, also bigger ones, also more professional ones coming from external authors. We are working on that Circuit Special at the moment. And we will have about 60 articles at the end, amongst 50 of them projects, some with PCBs. And yeah, it will be a very good special again.
That's great, Jens. I love to see something physical moving on a potentiometer. It's like back in the day, you had 0 and you had 10, and it would stop there. But now with remote-controlled amplifiers, for example, I have a Sony home theater amp. You turn the dial, but it doesn't ever stop anywhere. It just goes up or it goes down, so that you can also control it with your infrared remote control. But it would be great just to have a lovely tactile switch to see something actually moving.
Yeah, in fact, these potentiometers, they are moving. They are from the classical type. And yeah, exactly. They have a start and they have an end. Yeah, and we first thought to really fiddle that is it called wave? Or no, it's in German, it's Welle, so that axis through the housing, but yeah, it was mechanically too complicated. So in fact, you cannot configure the volume in the classical way in our approach anymore. So we also thought, yeah, when we have no Wi-Fi or the Wi-Fi is disturbed or something, how can we control it then? And then I had the idea to also have an infrared receiver, and you can see that infrared receiving diode in the foreground at the left. So that is our fallback if we have no Wi-Fi. But with these potentiometers, they are really made that you can still move them mechanically. So also against the motor, then the motor just rotates, and there is a Kupplung which makes that possible. So you can still rotate them.
I think it's great. Jean-Francois and Saad, you guys didn't have any moving parts in yours, so Jens has got the edge on you in that department. In fact, I think we're impressing the audience because Eric Janssen has bid €1. Do we get €2? €2, anyone, for this project?
But now the big question is, when is the disco party, where we can see your project in action, Jens?
We first have to test it, and yeah, maybe we are doing one, but we'll be in Cologne. But I will invite you.
Thank you. Yeah,
we will probably see you later in the year, so I definitely want an invitation to that. Just a reminder, Baltic Lab, I said to you earlier, has joined us. Hi, Baltic, and Elektor team, my colleagues in the background have been kind enough to put a link there to join the show, streamyard.com/watch/8, lowercase x. No, I'm not going to read that whole thing. You can go to our website, elektormagazine.com, and you'll see a news item about that. Visit that, sign up, and join us next week for that. Any other questions from anyone? Frank says, and he's correct, ESP now, no Wi-Fi necessary. What do you guys think?
Well, if there's a mesh, then you can have.
Does not have Wi-Fi, but carry on about the mesh. Sorry, Saad, to step on you.
Yeah, so if you have a mesh, Wi-Fi mesh, then ESP now is good. So you don't need Wi-Fi. On the field, you can just have 2 ESPs, and then one connect as a server, the other can be as the other side, and then you can control everything by one device. But
that's exactly how we do it.
Solution. Yeah.
Peter Gilbert, thanks for joining us, Peter. He says, thanks for another enjoyable afternoon of electronics. Well, I certainly enjoyed that. Are you guys looking forward to the Circuit Special? I am. I know we have a lot of work to do to get it through the final stages, but it's looking good so far. A lot of very interesting projects coming up.
Yeah, looking very good. I'm happy to see it printed soon.
Well, seems like we've run out of questions in the chat. Let me have a look once again. Thanks again, Peter. Let's have a look at what's coming up on our next lab talk. So we've decided to take on the topic of AI at the edge, which means local AI processing on your device. So that could be your PC or your ESP32 or your Raspberry Pi, which I'm busy fiddling with at the moment. But you can do image recognition, speech to text, image processing, object detection. And yes, Saad has been making great inroads into that as well with his object detection project. And Jean-Francois is working on it, and Jens loves it. He doesn't want to talk about ChatGPT and Midjourney and Leonardo. He wants to see it running locally on devices. So we're going to give that a bash, and then we'll talk about that, among other things, in the next Elektor Lab Talk. Plus, there'll be some surprise products released that we'll be able to talk about then. So that's on Thursday, June the 20th at 16 hours CEST, summertime, or that's 10 a.m. if you're on the US East Coast, or 14 hours GMT UTC. So that's it. Thank you very much for joining us, everyone. And I hope you're looking forward to the next one. You can keep updated on our upcoming shows by scanning the QR code or visiting that URL. It's on screen. I don't need to read that again with all those dashes. We really need to get a short link for that. And thank you for joining us, Saad, Jean-Francois, Jens Nickel from all over the world. And thank you for the viewers who are joining us from everywhere, from North Carolina to the Netherlands, Belgium, France. It's great to see. I love this. We live on one unified planet. And you know what? Even 20 years ago, it was impossible to think about what is Jens doing right now in Aachen? How can I help him? But now we just have this technology at our fingerprints. Back then we'd need a TV studio and satellite uplinks and all that kind of nonsense. But it was great to see you guys again. Thanks for coming through.
Thank you, Brian. That's nice to see you guys.